In this video, I'm going to be going through Darlington pairs. As a precursor, you should watch the video I have on transistors. Oh, and throughout this entire video, I will only be going through Darlington pairs with NPN transistors. So, what is a Darlington pair? A Darlington pair is made up of two transistors, in this case, two NPN transistors. But they could be made of more. Basically, a Darlington pair just consists of a few transistors connected together in such a way, in this kind of way. An example of a Darlington pair with more than one transistor would be something like this. So here we have a normal Darlington pair, right? Then we treat this like its own diode. Then we add another diode before that, so it will look something like this, or in simplified terms it will look like this, but we don't need to learn that. So the Darlington pairs that we'll be handling will be Darlington pairs that only consist of two transistors. Okay, so what does a Darlington pair, right, actually do? Basically it it takes in an input current, and then it amplifies that input current at the output, or basically it amplifies the current at the emitter lah. So I will go on to show you how that works later on, but there are some things you need to note about a Darlington pair. So we have this Darlington pair here, right? And then we still have these three legs like we would have with a normal transistor, and we can actually name them in the same way we would with a normal transistor. So this up here will be the collector, which will provide current to the collector pins of both transistors, and this can be labeled the base, which provides current to Q2's base. And then we have the emitter, which is the emitter of Q1. And also note that the emitter of Q2 is actually connected to the base of Q1. Oh, and you will have to memorize how to configure Darlington pairs, as the questions in the examination may ask you to draw a Darlington pair configuration. Okay, and you can see, right, these equations should look familiar because they are exactly the same as with a normal transistor. But one thing to note is that the gain is IC over IB, which is normal, but the gain can also be written as the gain of the first transistor multiplied by the gain of the second transistor. Okay, so that is something that is important as well. So now I'm actually going to demonstrate um, how a Darlington pair actually amplifies. Okay, so we're going to look at an example here. So we have one circuit that has one transistor, and we have a circuit that has a Darlington pair. So let's get into it. Oh, and I think this is actually doable if you don't know anything about Darlington pairs and you've just come on here now. This should be doable as long as you have normal transistor logic. So it's okay if you want to pause the video to try it first. So let me describe this here. We have a component A, and the component A only turns on when the current is higher than 10 milliamps, or in other words, the current at the collector is higher than 10 milliamps. The other information we have is that the current at the base is 4 microamps, and the current at the emitter is 2 milliamps. So my question to you is this: in this scenario, does uh, does component A turn on? So you can pause the video now to go ahead and try it out for yourself. So let's do some calculations to find out lah. So how I will approach this is that I would try to find what is IC. So I don't know what IC is right now, and I'm going to try and find that. And if IC, when we find it, right, is higher than 10 milliamps, then it turns on lah. And if not, then it won't turn on. And we can actually use the equation IE is equals to IC plus IB right here. IB plus, okay, whatever. We can use this equation, and then we will get 2 milliamps is equals to IC plus 4 microamps. And with this, right, we can actually do some basic algebra to get the value of IC. So it'll be this. Then of course, don't forget to convert your prefixes. It will be like this, and then we can just put this in a calculator. So I'm going to go ahead and do that right now. Okay, and that gives us around 1. Or it gives us exactly, sorry, 1.996 milliamps. Yeah, okay. If you don't know how I got milliamps, I basically looked at my calculator, and then I just see that there is a times 10 to the power of negative 3 prefix, which is milli, on the number itself. So that's how I get milliamps here. So the current at IC, or IC, is 1.996 milliamps. And since 1.996 milliamps is actually smaller than 10 milliamps, then component A does not turn on. Yeah, so that's the answer. And then now let's move on to application of a Darlington pair. Now we see that there is a Darlington pair, and the information they give us is that the gain of this first transistor here is actually the same as the gain of the second transistor. Now my question to you is this. In this scenario, with the current, with IB being the same and IE being the same here, oh sorry, hold on, let me rephrase. Now here, with IB being 4 microamps, and with the information you have here, ignoring IE, can you tell me, does component A turn on now? So you can pause now and go ahead and try for yourself. So let's actually figure that out lah. Just by the looks of it, we are going to need the gain of one of these transistors. Any one is fine since they are the same. Sorry, let me rephrase. We're gonna need the gain of the Darlington pair. The reason why we need the gain of the Darlington pair is because that gain will be equals to IC over IB. And since we already know IB, since we already know the gain, or when we find out the gain, then we will know IC, and then we can compare it to 10 milliamps. So how do we get the gain? We can do that by multiplying the gain of Q1 and Q2, as it says over here. But we don't have the gain of either of those. So what we're going to do, we can actually find the gain from the first part here, because we have IC. IC is 1.996, and we have IB. IB is 4 microamps. So we can go ahead and just put those values in. So the gain would be IC over IB. Now it could be also said that you can't really use this value of IC, because in this scenario, IE is specifically 2 milliamps, which would be the reason why IC is 10 milliamps, or IC is 1.996 milliamps, but I don't think so. It's probably due to some resistances before IC and the power supply itself, which actually forces IC to be 1.996 milliamps. and as a result, IE in this case is 2 milliamps. Okay, this is just some clarification on whether IC is useful, but if you didn't get that, it's fine. So we just plug this, we just calculate this normally. Okay, we convert the prefixes, and then we can just put it in a calculator. So this divided by this. Okay, and then we get 499. So that's the amplification factor of one transistor. So now we need the gain of the Darlington pair, which would be Q1, the gain of Q1 and Q2, and since they're both exactly the same, we can just say 499 times 499, so that'll be 499 squared, and this in turn gives us 249001. Okay, I didn't really write it well. Okay, so now we need to find IC, which again we can just use this equation. So this would be 249001 is equals to IC, and then IB, which is 4 microamps, as we already know. So we just need to again convert some prefixes, convert the micro prefix, which would be this, and then we need to bring it over to the left, and then we get 996, around 996 milliamps. So in this case, it is not enough. Oh wait, it is. Sorry. Oh wait, I'm actually kind of slow. So 996 milliamps is higher than 10 milliamps, therefore component A will turn on. So yeah, there is actually an issue with this question, because, okay, no, it's fine. Okay, even if this question is wrong, at least the lesson still is held true, because this is how you find the gain factor of a Darlington pair. The reason why I'm making this video is because there has an issue has arisen, where some people can't actually solve Darlington pair videos, even though they know that the gain of the Darlington pair is the gain of the two transistors multiplied together. Even with the information, some still cannot answer. So I hope this video will clarify those doubts. Thank you for watching.